Everyone, this is the Container Identity Working Group for January 6, 2018. We're going to start off with Mike talking about token requests PR that's open.
Yeah, so this is the API types, addition of the API types that are discussed in the token request proposal, which seems to be winding down. The token request right now is going to be a sub-resource on the service account object, or the service account object. You should go check those out because I think they're pretty close to merging in their current form. So if you guys have comments, it would be good to make them sooner rather than later.
And can you just remind everyone, it's probably been a while, what the point of this is?
Essentially, it allows a client running as a Kubernetes service account to get service account tokens for that service account dynamically. And what that allows is audience attenuation, time attenuation, and yeah, that's actually the two attenuations in the initial draft, which are improvements over the current unbounded JOT.
So Mike, so the typical use case here would be somebody has a service account and they want to prove that they have access to that service account to somebody else. So they go through and create a sub token with a specific audience that they can then pass off. That other entity can then verify with that, but can't actually use it to authenticate back to the API server. Is that right?
Yes.
Okay.
Yeah, so this fixes the Vault use case. Cool.
Wait, just to be clear, and there's nothing in here that like starts mucking with what we lay down on disk or what the kubelet does, or sort of the interface to the node beyond just sort of new APIs that the node has access to, or that the workload has, right?
No, there's nothing like that. A doc exists about that, but it is separate. And Clayton wrote that doc. So I can poke him to send it out.
No, I think it's just, breaking this down into things that have independent usability, I think seems like a good way to go. And so this seems like a really good building block to me.
Yeah, I agree.
As anytime when we're mucking with the interface with workloads in a sort of deep way, I think that's a different level of diligence, I think.
Yes, I agree.
So there's one thing in here. So you also support binding tokens to Kubernetes objects, so that when the Kubernetes server checks the validity of a token, it will check that object still exists. Is that true?
Yeah, that's true. I didn't mention that as an attenuation because the current ID tokens have that attenuation.
So that still, though, a third party can't necessarily validate that attenuation.
Right. So they can either choose not to validate that attenuation or use the token request API, or token review API. So token review API will support validation of these ID tokens.
I can't think of another way around that, so it seems as
good
as any other things.
Or they can, I think the best thing to do if you want to make that assertion, I think it matters less if you have short-lived ID tokens and you put a short ceiling on how long those can exist. And if you really want to validate those, that attenuation, or if you want to support that attenuation, you need to use the token request or token review API to validate those tokens. And I can see it for some use cases. If it is inconvenient, it can probably be ignored, but for some other use cases where that security is a concern, it might be nice to just set that up. So that's how the Vault integration currently works. It uses token review API. So that should just work nicely.
Is there going to be any way to express a policy around these tokens, like in RBAC? If I want to say that this service account or whatever can get tokens for these audiences with these scopes or with this maximum duration?
In RBAC, you can configure who can get tokens for a specific service account. The maximum validity duration, and as is designed in the current proposal, is a global maximum set on the API server. And the audience is client provided and unbounded currently. I think like it makes sense for user OIDC flows to say this user is only allowed to get tokens with these client IDs. I'm not sure it makes as much sense for programmatic use or programmatic use cases like this. Do you have an opinion on that?
Yeah, I can't think of a scenario where it would really be unsafe to allow any audience.
Right.
And the policy for duration does feel like it would probably be a global thing, or at least like a per namespace thing or something.
Yeah, it's global, and clients can also request a specific validity duration that may be ignored.
So looking at the token review API, it now has a new parameter, which is the audiences that you want to review against.
Mm-hmm.
Does it make sense at some point, and I don't know if I understand all the scenarios, to essentially not pass, to always reject the token review unless there's an audience specified? So if you have an unaudienced token, should you ever be using that with the token review API? Now I know there's history, there's legacy with some of that stuff, so there's a slip in the clutch type of thing, but what do you think of that?
So this API as it exists today, it will not be able to create ID tokens that don't have audiences.
But you can take the existing service account tokens and reuse it. What I'm trying to say is, at some point, can we get to the point where we disallow the vault type of thing, where somebody's passing their super powerful token to some third party?
Yeah, I see what you're saying. I think to do that, we would just disable the legacy token authenticator. So right now, I'm planning on just having 2 token authenticators. The one that exists today, and having a separate but very similar one in that authenticator chain. And removing that first authenticator would remove support for validating old style JOTs, which would achieve your goal.
I don't know if that quite achieves it. Like, there's still the case where you take your Kubernetes scope JOT and you hand it off to whoever, and then they come back to the token review API and it still validates. I don't think it's on the token review to pick and choose what audiences it's willing to validate.
Well, I mean, that's a good, like, I think that might be an option, right? We might actually say that depending on who's calling the token review API, they actually are only allowed to validate for certain audiences, right? I mean, this gets a little messy, but I think it starts to disincentivize people from essentially passing around tokens willy-nilly without thinking about audiences. So maybe you have to register that, like, and this might look RBAC-y, but there might be a token review policy that says these principals can use token review for these audiences.
Yeah, you start to get into like OAuth registration style things.
Yeah, I know. But like, I'm really scared that people will just create these all powerful tokens and just pass them around willy nilly, because like that's just the easy thing to do.
Mm-hmm.
I don't know. That can
So
come
to
later.
clarify, the suggestion is to have a client who uses the token request API only be allowed to make token requests with a specific audience that is associated with that client.
No, I think
Not just making it explicit, but actually limiting which ones they can check as the audience. So if I am some integration, I don't have the ability to check tokens with audience API, which feels a little silly. Like if the token has been given to me, then I already have the thing that's valuable, and I can just go use it for stuff. So it feels a little bit like guarding the wrong end of the chain.
Yeah, it
I
feels
totally,
like
but it shapes
the idea,
behavior.
I guess is just to have the gentle downward slope towards doing the right thing, right? Which is not using those globally scoped or Kubernetes API scoped tokens. And I think the having the token request API here, this new API, require an audience is probably the right part of that slope.
Well, my suggestion explicitly is to have some policy, and again, this can be layered on later, that restricts the token review API, so that like even if somebody hands you one of these tokens that is all powerful, it will be useless to you unless you have the policy to verify that. And what that means is that somebody may give you the wrong token once, but they won't do it habitually because it just doesn't work.
Yeah.
So I guess to be a little more concrete, like if somebody right now has the Vault integration set up in their cluster, they upgrade to a new version of Kubernetes that supports this, we would like that to break, probably,
So,
or emit a warning of some kind.
So the Vault service account or the Vault user that's calling the subject access review or the token review API, that's calling the token review API would get a no unless it has the Vault audience in that token. And that would shape behavior, right? Because then nobody would hand Vault a widely scoped token because it just wouldn't work.
I would argue that we should change the Vault integration to do that.
Right. Yeah. So to be clear, I'm not worried about Vault because that's a one-off type of thing and that's high visibility, right? What I'm worried about is the long tail of people who are going to be copying this stuff, slamming things around willy-nilly and not think about it. And so if somebody has to explicitly say this principal is allowed to do token review with this audience, if that map is stored someplace and enforced server side, that'll shape behavior.
Would it be enough to just say that the token review API in a future version starts requiring you to specify the audience that you want to review against? And then the older software that didn't, like the current Vault integration, it would still break. It would still be the hint to the admin that you need to go do this better.
I don't think we're going to break it.
How do you say that the audience Vault corresponds to the actual Vault servers coming back?
So spitballing here, and again, this is past this PR because like this is obviously layers upon layers, but like this would be something like we'd have a token review policy object, and that would look a little bit like RBAC that actually says this principal is allowed to call token review with these audiences, right? And so that creates a map between principals and audiences, and then the token review would say no unless the person asking is allowed to do token review for that particular audience.
We could probably try that out with a pluggable admission controller once we have this API and see.
Yeah, perhaps. Yeah, I want to think about like ecosystem and how do we shape behavior and how do we actually create the right pressure so that people have to explicitly say, yeah, I want to do something dangerous and broken, right? We're not going to prevent them, but like if we can make it harder for them to do that. I just worry about people copy and pasting stuff until it works, and then all of a sudden you end up with a super insecure system.
Yep.
All right.
It's an extra step whether they do the right thing or not, though. Like, so if we want to make it easier for them to do the right thing, but this adds an extra step. And we want to make it harder for them to do the wrong thing, but this adds an extra step that allows them to do the wrong thing. So
yeah, I mean, we're never going to prevent them from doing the wrong thing. It's just a matter of, can we make it easier to do the right thing, or at least, explicit that you're going to be doing the wrong thing.
Yeah, it's an interesting idea.
All right, rant over. That's obviously goes beyond this PR.
Okay, so CJ, do you want to talk about the validated annotation stuff?
Sure, I will introduce Mike's other important PR. The idea that we have some set of annotations that are actually checked at admission time. And we had a specific use case where we wanted to be able to pass an annotation that said, I want this pod to run as this Google service account. And we want to do an admission check on that. That eventually just asks an authorization question of, is the caller allowed to run as this Google service account, which is a concept that we have in GCP. It sort of exists in other places too. We thought it might be general enough to say that there's some set of annotations that we want to have a general way of turning into authorization questions that we can ask your authorizer chain. And for example, on GKE, that would just go through GCP's IAM first, but you could also see a benefit in consolidating these sorts of things in your RBAC policy, as opposed to saying, well, my access control for who can run and who can have access to pods is in Kubernetes RBAC, but my identity policy for where identities get shoved into pods is in a different system. And if we had the option to at least be able to put those side by side in RBAC, you might be able to reason about who actually has access to what identities better.
So one question I had was, most pods are not created by humans, right? They're created by one of the workload controllers. So for pods that are created by workload controllers, who would we be checking the permissions of?
So I would assume that they would have the same sort of God rights that they have on other pieces of the system today, where if you are able to get a replica set through admission, then the replica set controller is able to do whatever. So
it's really not, though, because it can't bypass quota, right? I mean, there's like there's some things that we only validate at the pod level.
Yeah, the other policy types of control, so quota, nothing is exempt from quota. The security context, so pod security policy, the pod creating controllers don't have PSP permissions. You attach those to the service accounts in the namespace. I'm just trying to understand who the check is done against and at what point in the chain.
So I think the idea of this is that we do want the check against the person outside the system, whether that person is an external automation or an actual bag of blood. We want to check whether they are on some policy allowing access to that identity.
So you're not only checking pods, you're checking every object upstream of pods that can trigger a controller to
that we know about, yeah.
Pods? Huh.
So maybe it would be good to go over the problem that this is trying to solve and I want to explain why we think it's a general problem. Do you think that would be useful, CJ?
Sure.
The constraint that we want to make is that an actor in a system cannot gain access to another actor's credentials, identity proof, unless they have explicit delegation over that actor. So think of a system where Kerberos or GCP identities are overlaid over Kubernetes. How do we allow an identity integration to build a system that has this constraint? So does everybody understand the problem?
I think so, and I think it's my gut feeling is that this is not something we want to do, but
Why?
So the idea is that if I have access to create pods in namespace A, and namespace A has access to Kerberos identity B, then by transitive closure, everybody with access to A, namespace A gets access to Kerberos identity B. And what you want to say is that you want to connect the user that creates the pod to the permissions that pod actually gets. And I think this no place else in Kubernetes have we actually gone through and once objects are created, actually tied it back to the people who create those objects. There's generally this idea that things will be managed by teams, and if those teams come and go, if you have access to operate within a particular team, then you have access to do everything that team can do. If we have an overlay and sort of a matrix of other permissions, then it becomes much less predictable in terms of say there's an outage in an on-call situation. It's like, well, we need this particular person because they have the right matrix of permissions to be able to do stuff. I just think it's definitely breaking new ground from what Kubernetes has done before.
No, that is so. All right. Kubernetes has so far indirected through namespace and used namespaces as a policy boundary. An identity integrator wants to be able to make this constraint. How do they do this? How do they extend Kubernetes to enforce this constraint? Do you agree that we should allow an integrator to be able to make this constraint?
So the constraint. So what I would say is that if the integrator wants to actually say that, hey, server's account in a particular namespace has access to this external identity, then it's up to them to actually understand everybody who has access to that in Kubernetes and then make sure, and then maybe raise policy violations or actually sort of reconcile that and remove them with namespace access. So I think either the source of truth is the identity that exists outside of Kubernetes and use that to actually drive the RBAC system, or you take the RBAC system and say, if I add somebody to the RBAC system, they go ahead and they, and then that actually changes the other identity system, the other permission system. I think trying to actually do sort of an and between those two things is going to create a very confusing situation for folks. So I would say pick one source of truth and go with that, and then have the other one actually be secondary to the single source of truth.
Do we actually need like a new API that's like this, but is like a namespace access review, where you're actually doing an access check and say, does this namespace have permission to use this annotation value?
I think that is a subject access review in a namespace.
Although a subject access review in a namespace can be answered by the namespace. And I think what we would want there is, can broadly in the universe, can this specific namespace use something?
Yeah, that's fair. I guess it may, but you may not necessarily use the user at all in that decision, is what Joe's saying, I guess.
Yeah, I would say once you authenticate to Kubernetes, we don't want to make very many decisions based on the user that sort of goes deep and spiders into the system, because I think it makes working as a team that much harder.
I think it makes the audit story, if you have your authorization specified in a different system, it makes the audit story harder to say, to tell your central administrators, like, hey, I want to run Kubernetes for this team. And by the way, you now have to understand all of the Kubernetes indirection rules and all of the RBAC permissions that could grant access to a service account for you to truly understand all of the transitive closure of permissions that the service account is granted.
We're going to have situations where, let's take an example. It's like I have a pod. That pod has permission to access a Kerberos user, and I'm injecting the program because I'm in a serverless system using a config map. Do I now have to sign that config map? Having access in general to a namespace means that you essentially have root in that namespace. Right? We're going to see this happen again and again and again, where it's almost impossible to lock things down to sub namespace types of access.
I didn't understand the example. You said that you have a config map that has.
So okay, so the idea here is that I want, if user A launches pod, then I know, and pod uses Kerberos like thing B, then I know that user A gave permission to, is essentially blessing that pod with their Kerberos access or their GCP access or whatever. And what I'm saying is that is so leaky to almost be useless. There are so many other things beyond that single pod that can influence how things execute to the point where that is not a tenable defense boundary. If just because we can say like I launched a pod doesn't mean that I define everything that actually controls what that pod does. And I think the canonical example is anybody writing a serverless system that does sort of they launch pods and then there's another config map that actually configures what happens in that pod. It's a very common pattern. Now we have to lock down the config map. We'd have like to really lock this down. We have to make sure that the transitive closure of all the objects in Kubernetes that might affect the runtime are actually signed in a similar way.
I would argue it's a slightly different problem. Just because you're launching a pod whose explicit, like its program is to load a config map and run it. So by you launching that pod, you're taking on broader responsibilities than the Kubernetes system provides directly.
Right. Okay. So what are we going to do if somebody goes in and they launch a pod and then they go in and they edit something in the pod, right? At some point, we're going to maybe say, hey, you can, I have permission to exec into that pod. Right? Are we going to restrict who has permission to exec into that pod based on the signature?
That's what the proposal says.
So now all of a sudden this becomes a whole nother access system.
Yeah.
I mean, like just throw away RBAC. At this point, just throw away RBAC and actually have some other system that actually is sort of external to RBAC for actually just, controlling this stuff. I mean, that seems totally reasonable to me.
I followed you up until the throwaway RBAC and.
Well, what I'm trying to say is that like once you say that, hey, now this system is going to restrict who can actually exec into a pod, you're going down the slippery slope of finding all the different angles that people can use to actually work around the fact that Kubernetes doesn't really consider owners, right? There is no owner to an object in Kubernetes. Right? If we want to introduce the idea of owner and then we want to restrict things based on owner, all of a sudden we have a whole nother access system, or authorization system to consider. There is no person owner for Kubernetes objects, and that's what we're introducing here.
You're saying it's hard, but somebody needs to audit these permissions. Somebody needs to figure out who has access to identities, and especially when you start overlaying credentials of external identity system onto pods.
I would say the namespace is the thing, dude. I mean, like if you have access to a namespace pretty much in any way, you have access to any of the downstream identities that namespace gives you access to. Now we can audit things, right? I think it's totally reasonable to actually say, hey, the user who actually created this object, we actually leave a breadcrumb someplace saying that, hey, that user created this thing so that you can actually sort of trace back who last touched it. Right? And I could see us having events or an audit log of all the people who've touched the definition of that object. And then you can spider out and actually do sort of forensics in terms of when things go wrong. But in terms of auditing who has permissions, trying to lock this down finer than namespace, in my mind, is a fool's errand.
So there's still nothing in this proposal that cares about the owner of a pod after it launches, right? It's still just an access check when it launches or when you exec into it, you like things that already trigger access checks.
And it's not a singleton, yeah.
It's almost like a new sub-resource that has its own policies that are separate from the object policies. Is that fair?
Yeah, it's a grouping of you can think of it like that. It's a grouping of the any action that would grant a user access to the pod's runtime environment, where they could potentially exfiltrate credentials that the pod had access to.
So you could implement this right now with an admission controller, right?
Yes.
And this is basically it's RBAC can express policy about the object metadata, but it can't express policy about this sort of thing that's sort of like a sub-resource.
So Mike,
this is
this
sort of
was kind of
expanding that.
this was kind of what I was asking the other day about whether this annotation was the thing that drove the credential being available. Because if it both drove it and via admission gated access, then I could actually see this working, right? So if I wanted a GCP credential in the pod, then I indicate that I want that via this annotation. And when the pod is created, I think you still need to check access. But then if someone tries to remove that annotation, or if someone tries to, a user tries to update the image or exec in or attach in, the admission controller can do checks at that point. So if it is both driving whether the credential shows up in the pod and gating access, I think you have a chance. But you still have the problem with controllers creating these things. Like, I don't know how you get the original human user plumbed all the way down in.
I mean, that's the thing, is that like really to really get what you guys want here, we might as well introduce an owner field in the object meta, right? And then that ends up being propagated in by something that has root to be able to sort. I mean,
We don't. We want to check those up front because we want to fail up front. We want to check every type that has a pod template embedded.
But you're not going to know about all the things that are building on top of Kubernetes. Like the point of these is that you can come in with other workload driving APIs, or something can layer on top of deployment.
As the admission controller to say, if you want to add a widget to your API and a widget has a pod template, then go ahead and add widget to the list of things that get checked by this admission controller.
Yeah.
Like I mean, honestly, if you have access to a namespace, you have access to all the identities that namespace has access to. I think trying to lock it down any further is just going to end in tears.
I think we can do better.
And I think at some level you could try to make that argument about the cluster too, and we've been pushing on trying to make the namespace a decent enough boundary.
I agree. I mean, like, but I think one of the things is that, like, if this is a proxy for sort of owner, right? So like, having an owner thing, and somebody like, well, I guess it's not, because it's like you can have multiple people as long as they both have access to that particular downstream identity, can both operate on those objects. But it becomes this matrix of permissions that honestly, I think, like, you guys already have a problem with GCP with the matrix of permissions, where like somebody has admin, but they don't have admin because they have admin through like your authentication webhook that's not public, or authorization webhook that like ties into GCP IAM, but that's not the same as RBAC. So sometimes when people check RBAC, they get confused, right? I mean, you guys already have this issue with GKE. So this matrix of permission is just going to create all sorts of confusion.
I would argue that without it, it would make more confusion, because we'd be adding a brand new indirection into the space of like a namespace to service account that GCP currently doesn't know about. But that's a GCP.
But this happens all over the place. Like right now, the way that you get access to trusted registries, is things like secrets that sit in the namespace. And pretty much if somebody has access to read secrets in the namespace, they own that thing. And oftentimes when talking to things like GCP or even, Azure, those things essentially represent service accounts, right? So we already sort of like give an equivalency between namespace and service account when talking about access to trusted registries. And those registries, whether we like it or not, will oftentimes have privileged data. People will embed credentials in images because that's just what people do.
I think that's a different problem.
No, but it's the same side of it's the same coin though, right? I mean, like there's this idea that we have this equivalency between, if you have access to a namespace, you have access to pretty much everything in that namespace. And we have been creating equivalencies between namespace and identity outward facing.
I think in this specific case, we can do better, and that's what we're trying to show.
Also, I think the outward facing is more tied to the service account. So the identity that gets presented outward is the service account. Partitioning human access to a particular service account in a namespace isn't something we've done. But so basically, a namespace represents sort of a uniform trust boundary to humans, and then you can run subdivided workloads inside that namespace.
But I think, you know, honestly, with all the confused deputy issues around things like replica set and such, like generally having access to a namespace, if you can like trying to lock down those templates, we just don't have a way to actually sort of propagate the user through.
I'm not talking about locking down a namespace. I'm saying subdividing a namespace is useful to lock down a workload inside a namespace, but
yes,
from a human perspective, managing a namespace, whatever has been granted anywhere in that namespace, if I can create a pod, that's mine.
Now, I mean, and there's other systems too. If somebody actually goes through and stores the JSON key for a GCP service account in Vault, are you going to want to actually trace through the Vault system to do this? Because Vault has all sorts of different ways to authenticate and create equivalencies between identities. And that's all opaque to the analysis tools that you're talking about here. So if you want to do this sort of analysis graph of who has access to what things, you're going to have domain-specific knowledge of all the systems that might hold credentials anywhere. In fact, there was a startup I talked to the other day that does build this graph and make it queryable. I'm happy to introduce you to them. I think they just got acquired, but like this is a general problem, and I don't think that you can actually, you know, solve it by making every system be the matrix of everything and actually make this stuff totally transparent.
I don't think you need to make every system do it, but I think if we give the opportunity for systems to do it, then you can actually provide it in one place for the people that are willing to say, no, I don't want to use Vault as my indirection for identity. I want to use this one identity system, and please just tell me in this one pane of glass what has access to what.
I think so. One thing that I think is reasonable, and this might be something that I would think would be interesting, is if we can augment our authorization providers to essentially do a reverse mapping. So then you could go through and you could say, hey, we've created an equivalency between this namespace and this GCP service account. Hey, auth provider, can you do a reverse mapping of who would have access to this thing? And not all authorization providers will be able to do that reverse mapping, but you could actually, you know, make RBAC and the GCP one be able to do that, and then you actually can trace this stuff back through.
I'll have to think about that one more.
Yeah, I think it gets pretty complicated because you have to join the different charts from each provider into an overall map of what the permission landscape looks like. I have a different question. Suppose we want to add, all right, I'll say, you guys can tell me whether this is useful or not. Add a field to pod that drives a external identity system to give access to a external identity to that pod. So think of like a field on pod called identities, and you would say GCP service account A.
Okay, that seems reasonable.
That's almost what we were working
No,
toward.
but I think the question, I mean, you
Yeah.
could do that with an annotation right now, right? You don't need a new field. I think it's reasonable to think about, you know, the idea of validated annotations is somewhat interesting, except there is this question of how do we propagate those across controllers? And so the big question here is that if I have a controller that creates a pod, so we're going to say, okay, so we're going to have the identity section in a pod definition, and that's great. But now the question is, who gets to actually set those identity? What does that admission controller look like? Is it based on, hey, this namespace can do it? Is it based on, hey, this user can do it? Now, if it's based on this user can do it, then how do we actually back propagate that through through controllers, right? Because like if I can create a replica set and that replica set creates pods, that replica set doesn't necessarily propagate the fact that I'm the one who created the replica set down through the pods. And doing that across all the controllers, especially as we look at the explosion of operators and controllers that we see coming. And these things may not have pod templates. They may be more domain specific. I just, this is a huge change to Kubernetes to actually start creating, owners or subdividing namespaces in this way.
If that is the solution, which it may not be, to propagate the original creator information.
Yeah. So I'm totally in favor of saying, hey, look, when you have, and I think if you look at the AWS IAM system, they do this. I'm totally in favor of saying, like, we want to start the pattern where controllers actually use some sub-service account to actually create the downstream objects, right? Because then we can start locking down and we can actually have those controllers act within certain scopes. So I think that's an interesting thing to start exploring. But then we're still creating the equivalency between, hey, this service account inside of Kubernetes is allowed to use this GCP thing, and we still have a level of interaction between the human physical user and the downstream identity. So we're going to have that level of interaction, I think, almost regardless.
But it's something that we need to figure out if we want this field to drive access to an external identity.
So I think having a pattern or a set of annotations that say, allow external identity to this pod, totally great, right? I mean, because we've been using service account as the proxy for that, but actually making that be more direct, totally on board with that. Like I'm thinking like in terms of Spiffy, right? We've been assuming that there's been an equivalence between Spiffy IDs and service accounts in Kubernetes. It doesn't have to be that way, right? We can actually create a more flexible mapping. The big question is, what admission controller actually goes through and actually validates those annotations, and how does it make its decisions? What are the inputs to that? And I don't see a way to make that not have a level of indirection without overcomplicating or changing Kubernetes in a pretty fundamental way.
All right. CJ, what do you think? I think that I can go back and rethink the delegation through different layers of workload controllers and confuse deputy issues.
So my knee-jerk reaction on that is just that we can validate it at the controller level. If you build a new controller, we can say either you just go ahead and grant this full powers over anything that that you want the external system, or anything in the external system that you wanted to have access to. And you just tell your external system, hey, my new widget controller gets all the identities. And then you optionally add your widget controller object to the list of things that get checked by an admission controller.
But I think you guys are viewing controllers as these heavyweight sort of like admin installed things. Like think in terms of Google's use case with respect to the MapReduce master, right? So MapReduce launches and then it launches all its subtasks. It's a controller, but it's a user specified controller. And when that works inside of Google, the MDB group is the thing that dominates, not the user who launched that MapReduce. And those MapReduce, especially with things like worker pools, can be administered by a team. And so just like the MDB group is the thing inside of Google, the namespace is really, like, we have service accounts, but for all intents and purposes, the namespace is the identity inside of Kubernetes that things act as.
Again, I would say the namespace is the security boundary. Within that, we give users
and we want
the ability,
to
the tools to carve up like a particular thing. But the namespace is the security boundary.
From the human point of view.
And I think that's where quota is going to live. I think for user-run controllers, which are a thing that we see more of and want to enable more of, you're going to keep coming back to attach permissions to service accounts, carving up a namespace if you want, or just use the default one in the namespace, and that's where quota and that's where permission boundaries live.
I mean, I look at things like the Kube meta controller. I look at the meta particle stuff that Brendan's doing. I'm not like, I think he's exploring some interesting ideas, but like this stuff is not going to end, right? Controllers are going to get more widely used. They're going to get more granular, and we can't just have sort of a universal whitelist of controllers that get to like escape out of this mechanism. So unless we have the controllers run as the people who actually, now we actually say, okay, instead of like, we don't, like if we introduce an owner thing to every object, and then that owner is the thing that's used. And so that means that when I'm running my controller, it's running as me, and that me actually has equivalency outside of Kubernetes and has the equivalency. But like that all of a sudden makes team management of resources that much harder.
Yeah, and that has its own problems with updates, and
it becomes a disaster. So I would say think through the MapReduce, the Google MapReduce scenarios inside of Kubernetes.
Okay. Yeah, and I think we have the stuff there to prototype this out today. If we just pick a prefix on an annotation that we decide is going to be validated for now.
And that's fine. I think it's just a matter if you're going to start whitelisting which controllers get to actually sort of propagate these things and which ones don't. That's, yeah.
So in the end, so let's say you validate this annotation ends up on a pod. And then you have some kind of node agent or something that is then injecting credentials. There's going to be another access check when that agent goes out to this external identity system and wants to mint a credential, right? So a lot of this is all about just failing faster, right? Because in the end, like that's the actual check.
But who is that checking against? Unless that has the information about the originating user, who is it checking against? Your options are the namespace or the service account.
Yeah, I don't think you can trace it back to the original user.
And I don't think that's what we're proposing. I think we're proposing that you trust the master. You say, I trust this Kubernetes cluster to do all of the checks that I want it to do. And if in any way this Kubernetes cluster has attested to this pod having this identity, I will trust that. So
and I think if all we did was create pods directly, that's one thing. But like once you add controllers in the mix, and not just the system controllers, I just have a hard time seeing how this is going to work.
I think it's possible.
All right.
So I think what Joe is arguing for is to tell external integrators to use namespaces and use the permission boundaries that we have so far used. My question is did this model grow semi-organically? Is this like a good place to be in? Do we want to improve? Is it acceptable to force people to adopt the Kubernetes namespace model of policy management, which is it doesn't map very cleanly onto other policy systems? Does an integrator need to adopt that?
In my mind, I think, this grew out of the experiences at Google where namespace approximately equals MDB group, because inside of Borg, the MDB group defines your namespace. And so I think that influenced this stuff early on. In some ways, the namespace is a role, right? And if somebody has access to that role, then they get to act as that thing when they're doing things. And that's sort of how you do, so I think the fact that we have roles and then sub roles is really what's going on here. But in reality, when we're talking about mapping this to other things, access to the namespace is access to that role, and that role is the thing that has permissions to do stuff. Does that make sense?
I'm still trying to understand, just because role is overused in different systems.
Yeah, but I'm just trying to say is that to some degree, we don't have because of the confused deputy issues around controllers, everything has to get laundered through a service account to actually act. And access to that service account, essentially becomes access to the role. And RBAC doesn't have anything to lock things down sub namespace. So you combine all that stuff together, and really the unit of trust ends up being the namespace. And so with respect to external systems, especially as we do things like the extended JOT stuff that we just talked about, if you can get access to a service account, then you can represent that you are sort of part of that world. And so essentially the namespace becomes that unit of trust. It becomes the things that you sort of like bind things through. And so really is equivalent to a role in a sort of larger RBAC system. I'm confusing everybody else. Shut up.
But we also want to introduce things like service identities, which don't map very well to that, in the sense that they're
for serving service identities.
Yeah, I mean there would be lots of services in a role in that view, and it's a kind of weird crossover.
Yeah, but I think generally, like, because, like, okay, so if we take service identity and we say that lets you get a serving TLS certificate, that's based on the service. Well, the service can really point to anything, honestly, inside the namespace is typically how it's used. And so really that namespace owns that service, and it's just a detail in terms of which pods are implementing it. And so, like, as a rough approximation, if a pod's running inside of a namespace, it should have access to the serving certificates for all the services in that namespace. Now we could lock it down a little bit further, but if you have, but if you can go ahead and rewrite the service, then you have access to sort of like, you assign it to any pod you want, right? And then that ends up being so the namespace is the thing.
I would try to channel Jordan here that you wouldn't actually want the pod to have access to all the serving certs. You might administratively have the ability to give the pod all the serving certs.
Right. But I think, totally agree. I think we do want to do least privileges pods, but really, as soon as you give that pod access to the API, the Kubernetes API in any way whatsoever, you almost give it access root on the namespace. It's very, very difficult to give scoped access to a single pod that is in any way useful.
To a pod, yeah. I think things like secrets and config maps, you can parcel out to a particular name.
But as soon as you assign a service account to a pod, like, it's like either you're using that as an identity token to talk to other things, which is the previous discussion we had, which is great, right? Or that thing is talking back to the Kubernetes API, and like with RBAC as it is, like pretty much now you have root in the namespace.
No, there's all kinds of read-only discovery types of things that are used quite a bit, actually.
Okay,
so,
maybe I'm being a little bit a little bit overwrought here.
Yeah. There's a spectrum.
Okay, I think we might call it. We're almost out of time, unless we're. I think
sorry, guys. I'm happy to talk about this more deeply with you guys one-on-one if you want. If you want to, like, I hate crapping on stuff like this. I'm sorry.
Yeah, Joe. Like, this is definitely like being driven out of like our interest from our production security side that are trying to reason about how these permissions actually work in the cluster. And so I think it would be interesting to get them and you and us and
and my take on it was look at MapReduce, right? I mean, like, how does Google do this with MapReduce? And my guess is that any tracing systems they have look at the audit logs coming out of Borg. And so that tracing system knows about Borg. It knows how to actually trace things through Borg. We're gonna have to do the same thing through Kubernetes. I don't think you can make those analysis systems blind to Kubernetes. I don't think we can do that. All right. Sorry.
All right. Let's talk more. All right. Thanks, everyone. It was a good discussion.
All right. Talk to you guys later.